Welcome folks, back to this HEI distributor, the high energy ignition distributor that GM used from about 75 until the 80s somewhere. I'm going to show you how one of these things basically works inside, and while I'm at it, excuse me, I'll show you how to get the cap off and the various wiring and whatnot. Okay, so to get the cap off, before I even mention that, if you are upgrading to an HEI distributor from an old points and condenser style distributor, make sure that you're getting 12 volts vehicle voltage going to this terminal under here in the cap. A lot of people, they'll just put their regular resistance wire from a GM vehicle on there, and then they wonder why their HEI distributor isn't working so well. So to get the cap off, it's just a simple matter of detaching the wires, meaning that you'll probably have that 12 volt battery voltage wire. You have to disconnect it. It's already off. This is out of the vehicle, mind you. Then there's another connector here that takes the wiring down to the base of the distributor. That has to come off. Okay, and obviously it's already done, but you can make sure you take your you could even put tape on and put numbers for all of the different spark plug cylinder numbers that the spark plug leads go to the spark plug wires, so you don't get them all messed up. It's like a big octopus. Okay, so it's just basically a plain tip screwdriver, and you've got four what look like screws, but they're just you just push down. They're spring loaded, and you turn them about 180 degrees, and then you'll get these little latch angles that come out that hold it on to the base of the distributor. So you just push down and turn it halfway, 180 degrees on all four of them. Okay, and then once, make sure your wiring and everything is off of there. In the vehicle you can even do it too and leave the spark plug wires on if you're still trying to do something with inside that's not involving the whole distributor out of the engine. Okay, so cap just comes straight up and off like that. Set to the side. As you know, if you had one of these before, the ignition coil comes out of here, and it's this one's just got two screws holding the cap that holds the ignition coil in the cap. So let's put that out of the way for the time being, and then you've got your rotor. Okay, and each and every time this is spinning around and lines up with one of these terminals inside the distributor cap, the high energy electricity is timed to make connection through the rotor button from the coil onto this spring-loaded metal strip. High voltage jumps from the tip of the rotor into each one of these contacts once it lines up with that, when it's turned to fire. Okay, so then to get the rotor off, it's just two Phillips screws usually. More high performance ones might be going with plastic screws so that you don't get a high voltage arcing or crossfire going on. I'll just mention a few things off the top of my head as we go through. But I've also got one of these loosened already to speed things up a little bit here. So this comes off, and I'll mention this now, is the indexing here. There's a notch just in one side, okay, of the rotor, and there's a little bit of a tab sticking out on this arm in the distributor rotor shaft mechanism here for the advance weights. So make sure when you put it back on, you line everything up and don't force anything. Make sure it all sits on there nice and pretty before you start to evenly tighten down the screws when you reinstall the rotor. Okay, so basically how they function, there is 8 sets of triangles, and the vacuum advance pulls that, and basically what it does is there's another set of 8 triangles, and I'll remove the distributor in a minute and set it on its side. And when each set of 8 triangles lines up, it sends a pulse to the ignition module. Okay, and then basically the ignition module is just a really fancy on-off switch basically that controls the voltage to the ignition coil, and I'll explain that in just a minute. Alright, so I'll show you those points here now. Hopefully should show up good at that angle in the video, but you can see when the inner shaft turns, what I'm doing is turning this, and I'll mention this now too. A distributor will turn 1/2 of the revolutions per minute, or RPMs, of the crankshaft of the engine, because of the timing chain and the gear ratio on the sprockets that drive the timing chain between the end of the crankshaft and the end of the camshaft on the front of usually a Chevy V8, say a 350 cubic incher. Okay, so now got it set that this thing spins 1/2 the RPMs that the crank does in the engine. Just to make sure that's firmly implanted in your head, because a lot of people get mixed up when you start talking about timing and degrees and things. Okay, so as this thing's spinning, this is a Chevy. Okay, so I should be spinning this way, clockwise. Okay, if you have an Olds or a Pontiac, chances are it'll be spinning the other direction, and your vacuum advance will be on the other side. Okay, remember I might have said this on a previous video where when you're going in, say if you were to squirt water, it would spin this thing that way. So the rotor and the advance mechanism would be spinning this way in a Chevy, and counterclockwise in an Oldsmobile or maybe a Pontiac as well. So watch your rotation, and this will dictate which way it's going to go basically. Alright, so there's those 8 set of triangles that I'd mentioned. When they line up, it sends an electrical pulse to the ignition module. Alright, so here we go. Like I was saying, when those 8 triangles line up, electrical pulse is created as soon as it comes away from the triangle. When they line up, that is, and it sends a pulse. This is the same wiring that you have here. And this is basically telling it when to turn off. Okay, so what happens, I'll explain the way the older ones worked up until about 74. They use what's called a points and condenser system, and it was on a fixed 30 degrees for a V8 engine, meaning there's the points. When they're closed, the ignition coil is charging up. When they open, that tells the ignition coil for the field inside it to collapse and create the spark onto the secondary windings and out through whichever spark plug wire that's lined up for that rotor in the distributor cap there. Okay, so basically I've only got a 6-sided bolt. Most bolts are 6-sided. This is what a 6-cylinder one would look like, only much smaller. I don't have an 8-sided one, so I'm going to use this just as an example. And this rubbing block here on the points where my thumbnail is right there, that last piece of that black plastic. So in a Chevy we're turning clockwise. This angle here is 30 degrees, okay? So what that means is for 30 degrees of the distributor shaft rotation, that is the amount of time that the points will be open. Meaning when this, not open, sorry, closed. When it's closed, and then when it hits the high point, it will open, and that'll be about 15 degrees, and then once it gets to the other side on a V8, it'll be another 30 degrees of closed time. Sorry about that mistake there. Okay, so each point that it hits, it will open the points, and it will create the spark, make the magnetic field in the coil collapse. Okay, so that was always fixed on the points and condenser type distributors up till about 74. That GM and other well, I'll stick with the V8s, it's just a little bit easier, but a 6-cylinder engine would probably have a cam with a points and condenser. Like I was saying, it would have 6 lobes on it. They wouldn't be this sharp, mind you. Okay, so that's basically it with the points one. It's at a fixed 30 degrees, and by saying that, we couldn't have full battery voltage going to the old points and condenser type one. We'd have to have a ballast resistor or an ignition coil with a really high resistance in it, and means for reasonably weak spark in comparison to an HEI distributor. The gaps, spark plug gaps for instance, on the old points and condenser type, most of that I've seen and set are 35 thousandths of an inch. And the bigger the gap in your spark plugs, the more voltage it takes to jump that gap, especially when you're talking about a high compression engine, and it just makes it that much more difficult for the spark to be created under those conditions. Now getting back to this ignition module here and how we compared it to the points, it's a variable dwell, okay? So what it does is it senses the pulses and how fast they're coming around. And say you're at idle speed under 1,000 RPM. Well, you can't, on full battery voltage, or even up to charging voltage, which when nothing's on in the winter could be as high as 15 volts DC. This will cut the dwell back. I've measured it once with the dwell meter while the engine was running in this particular one. And I was seeing 7 degrees dwell at idle speed. And what I've been reading is you might go down to 10 degrees dwell, so I can't see how accurate my measurement was, but I'm pretty sure I remember seeing 7 degrees only of dwell at idle speed. Now the faster you go, there's less time for the coil to charge up, so they increase the dwell. Now I can't really say for sure how high it'll go, but I would imagine it goes over the 30 degrees dwell that was that fixed value with the points and condenser system up till 74. Okay, so the dwell increases with speed because there's less time for the coil to charge because things are happening much faster. Okay, and from that point on there, I'll just mention another thing too is the condenser or capacitor, they work quite a bit different. On the one on the HEI, it's basically only well, I guess an interference filter, electrical interference filter, more than anything. But on a points and condenser one, if this wasn't the right rating in microfarads, the points would usually arc and burn up in no time at all if this went kaput, so to speak. So it had to be the right value, and to make sure that the points would survive. And another thing too is they couldn't have such a high amount of amps going through this, otherwise the points couldn't take it. They would just destroy themselves. Whereas with the HEI distributor, the ignition coil here, and because they're controlling the dwell, they can make sure that this isn't being overcharged by the dwell time. So if the dwell time, or in other words the time that the ignition coil is turned on, is too long, this thing will probably overheat and burn up. And conversely, if there's not enough charge time for the amount of RPMs that the distributor is spinning at, then it won't have as high a voltage output. So it's got to be just right, in the sweet spot, so to speak. So that's a very important part of it, is that ignition module. And so that's basically how the ignition coil gets charged up. Not too little and not too much for a given amount of speed that this thing's spinning at. Now we can get on to, let's do wide open throttle, pedal to the metal time. What's happening there is at idle, you have these advance weights here. You see they're spring loaded. They're calibrated, they've got part numbers on them, and the center plate here, or auto cam as it's a lot times referred to, is when this part of the advance weight comes around. It has a certain profile on it which will help dictate at the amount that these things will swing out. They're also called fly weights. Old school name for them is fly weights, because that's what they do, they fly out. So you got to remember, this thing is spinning on a Chevy clockwise like this, okay? And when you're at idle, there's not enough centrifugal force in order for these weights to overcome the power of the springs pulling them back, okay? So the faster the engine goes, okay, the more that these will start to swing out. And the reason I'm doing this stationary is because if this thing was in a running engine, say if you could have a running engine, which you can't in this case, you just see a blur because everything is spinning so fast. So the faster the engine turns, the more these fly weights or advance weights will sling outwards, okay? And you notice too also these arms that secure the rotor, they're also moving at the same time, okay? So you really had to watch that. Something I'll explain later is rotor phasing with the distributor cap terminals to make sure that the spark gets to its intended terminal without jumping around to the wrong place or missing altogether. Okay, so I'll actually explain too how you can change how fast these weights sling out, even a stop thing. With the older points in condenser 1, there was a pin underneath the autocam plate, and it would usually, you can see a slot right in here, and there would be a pin that actually hit and would limit the amount of mechanical advance the distributor was getting. But in the case of these HEIs, at least this one anyways, it doesn't hit the end of a slot on either side, as you can see there. They're depending on this little ear, if you will, of the advance weight itself to come and lay, well, you could say it's almost laying flat against the autocam there. So when I pull on that, I can only pull so far. You see, I can't go any further, right? I'm pulling pretty hard here. Okay, so that takes care of wide open throttle. That's all you're using there is your initial timing, wherever you set this statically on the harmonic balancer, if you want to call it damper on the front of the engine, without the weight slinging out. You want them to stay in, otherwise you're going to have an errant reading, and probably initial timing they won't stay put and stationary and still. So as say if you're wide open throttle, pedal to the metal, as engine speed picks up, it'll come out until you hit the maximum. And this HEI, this one is from a smog emissions engine, and it probably won't even get fully out until you're over 4,000 RPMs. Whereas a performance distributor for, your Camaro, your Mustang, or whatever, it'll probably be fully out by the time you hit 3,000 RPM on the crankshaft of the engine. And that's that part for the advance weights. If you're cruising lightly, just doing like regular driving from stoplight to stoplight in the city and really easy on the throttle, what'll happen is, depending on how you've got this set up and how it's calibrated, this vacuum advance unit here, it says it's got a part number with a 15 on it, and I'm pretty sure that 15 is in crankshaft degrees. And if this fully deployed, it'll add an additional 15 degrees of crankshaft, or 7.5 degrees at the distributor. Like I was saying, the distributor is half the degrees of advance that you would see at the crankshaft. and what it does is when the vacuum is pulling on the diaphragm inside the vacuum canister here, your vacuum unit, there's an arm in there and it pulls on this just ever so slightly, okay, and it just advances the triangle. You remember the inner set of 8 triangles is going in the clockwise direction, so if we're, say, we'll stop it here, if we pull on this, it's going to get there sooner, right? So it's basically just trying to remember what gets there sooner. If it's getting there sooner, it's advanced, okay? So that takes that part for the vacuum advance, and that happens only under light loads. If you're doing pedal to the metal, wide open throttle, there won't be any vacuum. Your vacuum will drop as a result of your throttle plates or butterflies and your carburetor being fully open, and the vacuum level drops, okay? What I should mention too is the way I think of vacuum is difference in pressure or pressure differential, because the word vacuum, it's kind of confusing when you think about it. So just think about it as in terms of differences in pressure between atmospheric, whatever it might be, just outside the air cleaner in the engine compartment, and what's depending on what the carburetor is doing, where the throttle plates are, butterflies, that'll more or less determine where the vacuum is and what the engine's doing at the very same time. Alright, so basically that's how it works. In conjunction, not conjunction, I should say, you're not quite slung out here. Say we're going, say, 2,000 RPM on the engine and we're just cruising along, there's a good chance that the vacuum advance will be fully deployed. So you'll be getting 15 from that. But also you have to remember, say if you're using a smog initial timing on an engine, well, something like this would be 5 degrees before top dead center. And then you would add that 5 to there, you got 20 there, and then whatever the weights are giving you, the centrifugal weights, if they're fully deployed, this particular one is over 4,000 RPM before they hit there. So if we're part way at 2,000, whatever the amount of mechanical degrees, let's assume that it might be, just say it's 10 degrees, say, at that point when we're cruising along 2,000 RPMs, it's just advancing. What this does, actually, I should also explain that and show you, maybe if it'll show up, is when you're working the weights here, it will actually move forward the inner set of 8 triangles. And like I was saying, the Chevy is rotating clockwise, so when you can see the action there down in there, if you can see that one point on the inside between the 2 outer ones. I'll try to hold as stationary as possible. You can see, hopefully it'll stay put. I guess I'm holding the arm in the wrong place here. But you can see the movement there. I can get it moved so when the weights sling out, that gets there sooner, right? Because we're going clockwise with the Chevy. It'll be, like I say, opposite hand for an Olds Pontiac more than likely. Okay, I hope, if I didn't leave anything out, that is, I'm just going off the top of my noggin here, so to speak. I'm not writing any scripts or anything. Thing to be careful with when you're messing with ignition modules, I'll just mention this too quickly, is don't touch the terminals unless you've grounded yourself out a little bit on some cold metal that's not moving or dangerous, and that gets rid of any static electricity that you got built up in your body. Some people really get a lot of static. I've had a friend there, and boy, everywhere he went, he's touching doorknobs and making sparks fly. Another thing too is when you're installing one of these, or if you've taken one out and have to reinstall it, shine up the back of this and the mounting pad inside the aluminum distributor housing, and then make sure you use some heat transfer paste. Probably better off with something like Arctic Silver or the stuff that computer guys use. Dielectric grease isn't really made for heat transfer. Although some people have used it maybe more successfully on a stock distributor, but when things get more high performance oriented, there's a lot more heat tends to build up depending on the matching of the ignition coil to the ignition module. You really got to watch that as well. I'll go into more detail in the future with the more videos I'll be making on this series here, or in this series, excuse me, rather. So basically that's what's happening. Like I say, in a cruise, you'll have a mix of vacuum advance, and if you have lots of vacuum, this will be fully deployed at this 15 crankshaft degrees, and then you'll be partially out on your advance mechanism with your centrifugal weights here. So you'd have to add them all together. Your centrifugal, that's set once you clamp the distributor body down. In the engine, you add all that together, and that'll don't get confused with total, by the way, too. Use it as your total plus vacuum advance, because from what I understand, total was an old term that was used when vacuum advance were probably not even on the distributor itself. It was probably a racing term where you're mixing or adding together initial timing and your fully deployed mechanical advance, centrifugal advance, not including the vacuum. So be very careful. A lot of the things I've been reading on the internet, they're talking venturi vacuum, and that gets everything messed up, and then you get the different things going on here, and everybody's got a different description and using different words, and it's getting complicated. So that's about all I got to say for today in this video. Hopefully it helps you out somewhat in understanding how they work, and I'll be breaking it down piece by piece as we move along in this series here. So I hope you enjoyed it, folks. And until next time, have yourself a nice day, and bye for now.